Good morning, my dear friends. See now, yesterday in your class we have seen we were seeing how to calculate the ultimate strength of a rectangular section in PSC beams. Okay, sir. So now, if it is a rectangular section like this, then we came to know that the ultimate moment of resistance mu, okay, can be calculated by this simple equation FPU AP into D minus 0.42 XU. Okay, so now I said you that this equation is there on page number 59 also. You need not remember this equation, it is there in the IS code. Okay, so now this is the equation. Suppose if the beam is a flanged section, something yesterday we have seen, I took an example of a this thing now, T beam. Okay, if it's a flange section, we have seen the analysis here. The moment of resistance will be due to the web portion as well as due to the flange portion. Okay, so accordingly we have drawn the stress distribution diagram in the web. It is stress block for the web portion and it is the stress block for the flange portion. Okay, so if at all I want to find out the ultimate moment of resistance of such a flange section, then you have seen yesterday that it is given by this equation. Mu is equal to FPU APW into D minus 0.42 XU. This is due to the web portion. This moment of resistance is due to the web portion. Okay, plus this part 0.45 FCK BF minus BW into DF into D minus 0.5 DF. It is due to your flange portion. Okay, this is from contribution of your web. This is the contribution of your flange now. This plus this will give you the overall the moment of resistance. Okay, so now after seeing these this thing, now we shall take up one example and I will explain you how to solve it. Okay, see now I will read the problem now. Okay, a pre-tensioned pre-stress concrete beam having a rectangular section 150 mm wide and 350 mm deep has an effective cover of 50 mm. In the sense, here has given 150 mm is the width, 350 mm is the depth, and he says that 50 mm is the cover. In the sense, there he has kept the pre-stressing steel. Okay, since 50 mm is the effective cover, but now I think you can easily calculate this effective depth D. Okay, so this 350 minus 50 will give me the effective depth as 300 mm. Okay, 50 mm. If FCK is 40 MPa, in the sense FCK means it is the characteristic compressive strength of concrete. Okay, it is 40 MPa. FP is equal to 1600 MPa. FP means it is the characteristic tensile strength of the steel. Okay, FCK is characteristic compressive strength of concrete. FP means it is the characteristic tensile strength of steel. In the sense, 1600 MPa. In the sense, at this stress, your steel cable is going to fail. Okay, okay. So he has given FCK value and FP value, and the area of pre-stressing steel AP is 461 mm square. In the sense, this area of steel is now 461 mm square. So he has asked you to calculate the ultimate flexural strength of the section using IS 1343 provisions. Okay, so now we shall see how it can be now solved. Given that FCK is 40, as you know already, FP is 1600 MPa. Okay, AP also he has given 461 mm square. Breadth B is 150. What's up now? Effective depth D, Baba, can be now easily calculated. As I have said, it is 350 minus 50. Okay, 350 minus 50 mm will give me 300 mm. It is D minus D dash. Okay, so now let us try to calculate one term. Okay, this term is called effective reinforcement ratio. Baba, this effective reinforcement ratio is given by FPAP divided by FCKBD. Baba, you need not remember this. I will show you how to remember, in the sense how to take this from the IS code. Afterwards, I will show you. But now, I want to calculate this value. It is called effective reinforcement ratio. Baba, FP I know. It is the characteristic tensile strength of the steel. Okay. AP is the area of pre-stressing steel, 461. It's also given. FCK is the characteristic compressive strength of concrete. It is given 40 MPa. Breadth you know 150 MPa, and D is the effective depth, that also you know 300 mm. Okay, so now this ratio works out to be 0.4. 0.4 is the effective reinforcement ratio. Okay, so now from this, what I want is, now I want to calculate two things. Now one, I want to calculate ultimately, see now ultimately your equation is this. I want to calculate the ultimate moment of resistance by using this equation. Okay, FPU into AP into D minus 0.4 to XU. But now in this equation, AP is known to you, it is given in the problem. D is known to you, effective depth 0.42 is also known to you. Now the only unknowns are XU and FPU. By XU means it is the neutral axis depth, and FPU means it is how much is the stress that exists in your steel cables at the ultimate failure. In the sense, during the failure, how much it has attained the stress, FPU. So now, if I know this FPU value and XU value, I think I can easily calculate this MU. So now, we want to make some circus to calculate this FPU and XU. And these two things can be calculated by using your IS code on page number, by using this table number 11. Okay, so table number 11, it is there on page number 59. Okay, so now how to use this, I will tell you now. Okay, see now. So now here I am showing you on page number 59. Okay, I am showing you this table number 11. See now here, if you just see here, it is APFP divided by BDFCK. Am I right? Same thing, whatever is there now, this IS code calls it as effective reinforcement ratio. Okay, same thing I have written here now, same thing I have calculated. Is it right? FP AP divided by FCK BD. Only thing is now slightly change in the terms. That's all. Okay, here it is AP FP divided by BD FCK. Same thing, FP AP FCK BD. Okay, so now you need not remember this. Okay, it is there in the code. Okay, you try to calculate this value. Okay, so this value I have obtained it as, what is that now, 0.4. Okay, 0.4. So now go to the IS code. This is your effective reinforcement ratio. Baba, in this, where is 0.4? You just search. 0.4 is now here. 0.4 is now last one. Okay. Now, I want to calculate two terms now again. FPU divided by 0.87 FP. Okay, FPU divided by 0.87 FP. Baba, your IS code gives, when you got effective reinforcement ratio of 0.4, okay, then for pre-tensioning, these are the values. For post-tensioning, these are the values. Okay, these are the values of FPU divided by 0.87 FP. Okay, so now see now. For 0.4, ours is a pre-tensioned beam, as you see. Okay, see here the problem. It is a pre-tensioned pre-stressed concrete beam. Okay, it is pre-tensioned. Please remember. Okay, so now you have to take this pre-tensioning. Okay, the value of this FPU 0.87 FP is, for 0.4 it is a 0.9. Am I right? So I have written here now from table number 11. FPU divided by 0.87 FP value is now 0.9. I have taken it from the IS code. And now next, Papa, here if you come here, this gives you XU by D value. This is for pre-tensioning. This is for post-tensioning. Oh sir, now XU by D value. See now again I will go to this 0.4. So for this XU by D value is now 0.783. Am I right? Because ours is a pre-tensioned beam. It is 0.783. So now I have written here now XU by D value is now 0.783. So now this value and this value has been now taken from the code book from table number 11, which is there on page number 59. So now I will use this one now. Baba, if I cross multiply this and this, I will get the value of FPU. So FPU, I can write it as now 0.87 FP into zero point 0.9. Okay, so 0.87 I know, FP value you know 1600, 0.9 as it is. So you will get FPU value as 1253 Newton per mm square. Similarly, XU by D now I will take now. Okay, so from here I can calculate XU value, cross multiply it now. Okay, XU by D is equal to 0.783. So XU can be written as 0.783 D. Okay, 0.783 D you know, effective depth. So XU value becomes 235. Baba, I came to know the value of XU. I came to know the value of FPU. So now you have got the equation MU is equal to FPU into AP into D minus 0.42 XU. Baba, fill these values now. FPU is 1253. Okay. AP also you know 461. Effective depth you know 0.42 as it is. XU value just now we have obtained 235. So you will get the answer as 116 kilonewton meter. This is the ultimate moment of resistance of that beam. Okay. Thank you.